Hello again. I'm just making a second video for lesson 6.6 because I gave an exit ticket. I'm really trying to get everybody ready for this upcoming quiz on right triangles, and the exit ticket was really a sneak preview of all the kinds of problems you can expect to have to do on the quiz, aside from the applications problems that you noticed in the last video. So I'm just going to go through the solutions really fast. The first page is two right triangle problems that you solve with the Pythagorean theorem. And remember that the Pythagorean theorem just says that the sum of the squares of two legs, a squared plus b squared, is always going to equal the square of the hypotenuse. And the first thing to ask yourself is, what's the unknown? And the unknown in our case on number one is the hypotenuse. It's the side that's across from the right angle. And then I can just put a and b here. And so I'm going to substitute 24 in place of a, so 24 squared plus, and then 45 squared is in place of b, and then I don't know c squared. Now 24 times 24 is 576. 45 times 45 is 2025. And let's add those together, and the answer there is 2,601. So can you find the square root of 2,601 in your head? That's okay if you can't. The answer is, it's actually exactly 51. And you of course always have access to a calculator in this class. So the first problem, by just using the Pythagorean theorem, we figured out that length was 51 centimeters. The second problem is just a little bit more complex, but let's do this one here. Now, which side do we know this time? The hypotenuse is given to us. It's C. And so what we don't know is, we can just call it A, and then we happen to know that this leg is 7. So let's write another example here. I'm going to write whatever. I wrote Q, so I'm saying Q squared plus 7 squared equals 9 squared. And now I'm going to do the same thing. 7 to the second power is 49. 9 to the second power is 81. 7 times 7 and 9 times 9. And then I'll subtract 49 from each side. So I have q squared equals 32. And so then the last step is to say that, well, q is the square root of 32. And I added an extra little detail to this problem. I want you to rewrite the answer in simplest radical form. And that's where we have to, again, figure out, well, what is a perfect square that I can divide into 32? And that's the answer there is 16. Because 16 times 2 is 32. The square root of 16 times the square root of 2 is equal to the square root of 32. All right, so the reason I split it up this way and not, like, a different way is that the square root of 16 is something I can do in my head. And so that's 4. And then I have the square root of 2 left over. So it turns out q is equal to 4 times the square root of 2. But then I also asked you to do it as a decimal approximation. And so if you use a calculator, like the square root of 2 is 1.414. And then I'm just going to multiply that by 4. So 5.7, if you round it to the nearest tenth. 5.7 centimeters. So those are the answers on those. And then the other page has 4 special right triangles, and we can do a couple of these really quickly. Again, so in a 45, 45, 90, I know that 2 sides are going to be congruent. It's an isosceles triangle. And the third side is just equal to that length times the square root of 2. So I can really quickly determine that P equals 3 because it's equal to this one, and Q equals 3 root 2. That's all you needed to do for that. Nothing else. The same thing here, we can do this one really quickly. In a 30, 60, 90, we say that the short side we call x, the long side we call 2x, and the medium side we call x root 3. And so since I know that this side is 42, I can immediately deduce that p equals 21. It's just half of 42. I just cut this number in half to find, because if this is x, this is 2x. And then I can also deduce that q equals just 21 root 3. And so these first 2 examples of the special rights are really the basics, and sort of the bare minimum to get like an L2 on the quiz. You have to be able to do that. The next 2 are a little bit more complex. So again, that number 42 comes up, but remember, these 2 sides are the same, and this one is that length times the square root of 2. The difference now is that I have to do a little bit of extra work to figure out what is x equal. We know that 42 is whatever this length x is times the square root of 2. So now we have to do that thing where we solve for x by dividing by the square root of 2. And so I have 42 divided by the square root of 2. Again, that's enough to find the decimal. But I want all answers in simplest radical form with rational denominators. This has an irrational denominator, which again makes me want to puke. So I'm going to rationalize that denominator by multiplying by root 2 over root 2, as you've seen me do in previous videos. Again, the reason is the square root of 2 times the square root of 2 is just 2. So now the denominator of my new representation is a rational number, and then the numerator has the square root of 2 in it, 42 times the square root of 2, which is, that's okay as long as the denominator is a rational number. And then if you can, you should reduce. 42 divided by 2 is 21. So the answer that we were looking for was 21 root 2 for both P and Q on this one. All right, one more to do. This one here, just like the other ones, we have to start by saying, okay, the short side is x, the long side is 2x, and the side that I know is x root 3. So I'm going to start with an equation. X times the square root of 3. The short side times the square root of 3 equals 14. Divide by the square root of 3 to get x by itself. And that means x is 14 divided by the square root of 3. Oh, it's in simplest radical form, I think, but irrational denominator means I need to rationalize that denominator. Let's multiply by root 3 over root 3. The reason we're doing that again is now root 3 times root 3 is a regular old 3. Right? It's a nice rational integer. And then the numerator is 14 times the square root of 3. So what I just did was, and I don't think we can reduce this, 14 doesn't divide by 3, so that's my answer for x. It's 14 root 3 over 3. It's 14 thirds times the square root of 3. But then finding the length of the hypotenuse is just a matter of doubling this. So I'm going to do 2 times 14 root 3 over 3, which is just 28 root 3 over 3. So that was my answer for that one. You're welcome for giving you the solutions to the exit ticket. If you haven't done it, I would complete it without maybe looking at these. But use this as a study guide for the quiz, and I'll catch you next time.